All right. For our final talk this afternoon, I'd like to introduce Anton Avrutsky, who's an adversarial collaboration engineer with the security consultancy Lares. And he's also a self-described fan of logs and queries, which I think a lot of us here at the Threat Hunting Summit can probably relate to. Anton's going to talk to us today about threat hunting against Office macros, like not just the old standards of like we have to disable macros and macros are evil, but rather understanding that some macros are useful, maybe even business justified, and how can we tell the good ones from the malicious ones at scale. So Anton, thanks for being with us today.
Awesome. Thanks very much for the introduction. So this is Hunting Malicious Office Macros with myself, Anton Avrutsky. It's a huge honor and privilege to be here. Thank you very much. And just a quick note before we get started that all the materials for the slides, including the diagrams, the Sysmon configs, the presentation itself and everything will be on this GitHub link, which I'll make public as soon as the presentation is done. And a quick note just about me, as David mentioned, I'm an adversarial collaboration engineer at Lares. I do purple/blue team engagements, and obviously I'm a logs and query and detection fan, so I'm among my people here. On Twitter, Anton loves DNB, and my email is just avrutsky@lars.com if you ever want to email me anything or talk shop. So what is this presentation about exactly? To begin, I want to touch on baselining Office macro activity. And we hear a lot about baselining, but there's not too many resources on how to actually perform it. And once we have our baseline, we'll have an idea of what malicious or abnormal looks like in the context of Office activity. So I want to talk about alerting and hunting techniques as well. And it's very difficult to have kind of a binary yes or no malicious benign type alert or hunting logic when it comes to malicious Office macros, as there's a lot of variables involved. So I want to also cover some alerting and hunting strategies. And it should be noted here that I'm using the term alerting in both the traditional SOC sense, so tell me that something was malicious, as well as in the sense of alerting you to the fact that these particular macro executions are worth a second look during a hunting engagement, and this could be turned into an alert kind of down the line. And obviously Office itself is comprised of many products, so we'll focus on Word and Excel exclusively as they're kind of targeted more often. And we'll be looking at endpoint telemetry and particularly Sysmon as it's freely available. But the telemetry that Sysmon provides is often similar to what is found in many EDR products as well. So why the kind of focus on macros? And if you're a numbers type person and you look at the total number of groups found in the MITRE attack matrix for the Windows platform specifically, about half of them utilize this user execution malicious file technique. So it's a pretty large swath of threat actors that are kind of using this technique to gain initial access. If you're more of a qualitative person and you're more of like a wordsmith, if you read any kind of threat intel reports, you can see that intrusions often begin with some kind of malicious Office document that a user clicks on and executes. And a huge shout out to the DFIR report for their awesome reporting here. I'm sure many other speakers covered this as well. So if you've ever worked for or with an organization and have brought up any type of macro controls, you've probably heard this phrase. And my team and I, when we perform purple team assessments, and obviously when we do these, macros feature heavily in our toolkits. And unfortunately, to put it mildly, EDR performance when dealing with these kinds of malicious macros kind of leaves a lot to be desired. So we often suggest a lot of hardening strategies for macros, and we're often met with this phrase. And from a business context, I think that this is obviously understandable because outright disabling macro executions in a business environment will obviously break business processes and will prevent people from doing their jobs, which is something that obviously we don't want. So let's break the problem down a little bit. We know that macros are a problem, and we know that users are utilizing these macros, so we can't outright disable them, at least for now. So let's try to break the problem down a little bit. And here I like to use a little bit of a visual aid for this. And There's probably many ways to kind of tackle this issue, but the blue teamer in me wants to start with gaining visibility into macro executions. So I'd like as much visibility around macros and processes and files and network connections and image/DLL loads, as well as various registry settings. After we have that visibility, the next step is to baseline the activity. And it's important to know whether macros are being executed at all, where they're running from, who is executing them, and where they're executed from. So for example, a trusted file share versus Outlook. The other good thing to know is kind of what the process trees look like and so forth in terms of data visibility. So once we have a good baseline, odd or malicious activity will start to stick out a little bit more. And when we test various payloads, we can see Office products dropping suspicious files, editing suspicious registry keys that they normally wouldn't, loading strange DLLs, making weird network connections, and so forth. And we could also see whether the macro was opened via file share or via Outlook. So once you've gained visibility and baseline behavior and have a good idea of what malicious or abnormal activity looks like, the next step is an alerting or hunting strategy. But before we dive deeply into that, I just want to touch on actually how to perform the baselining activity. So as part of this talk, I'm releasing 3 different Sysmon configurations. The first one is Office Watch, which basically says, show me everything that Word and Excel are doing. Office Shush then takes the activity from Office Watch and filters it out. So please note here that Office Shush is not 100% shush. It gets you about 70 to 80% of the way there in terms of noise reduction. And then Office Sus, the third configuration file, only contains the activity that we deem abnormal or outright malicious, or at the very least, that's worth looking at. And as another reminder, all these configuration files will be on that GitHub link as soon as I make it public. So to expand on baselining a little bit more, the idea here is to use Office Watch to see all Office activity, use Office Shush as a test configuration file to test various payloads against, and then you would add the activity that shows up here to Office Sus, where it can be added to your kind of main Sysmon configuration file or your own telemetry sources. And just a quick shameless plug here while I have the stage. We released a tool called Sysmon Config Pusher a few months ago that makes it relatively simple to flip back and forth between various configuration files. So if you're testing these 3 files on a bunch of hosts, this app might help you out and make it a little bit easier for you. So, all right, we spent hours flipping between Sysmon configuration files. We got a bunch of Notepad++ tabs open. We're all over the place. We've baselined our activity. So what kind of interesting events are starting to bubble up as a result of our baselining? And on the slide here are just some basic examples. So on the top left, we could see the VBE7 DLL being loaded, which only occurs when macros are executed from an Office product like Word or Excel. We see a trust record modification directly under that. And if you're interested about what this event is, outflank.nl has a great blog on it, and I'll post a link for that in the Slack hallway channel. We could also see the Windows script host library being loaded on the top right picture. And we also see some really interesting granted access values for the process spawned from Word on the bottom right image. And this doesn't cover all the interesting events, but right away, we could kind of see the fruits of our baselining labor. To further highlight some of these little nuggets that are starting to bubble up, using our command line data, we can now see whether a macro was run from Outlook or from a trusted file share. And looking at this amazing PS app for Splunk, we could kind of see what it looks like when Word spawns a process and how that process tree looks different when Word is launched from Outlook versus when it's launched from Explorer. So let's step back for a second and kind of regroup ourselves. With some visibility and baselining, we just went from knowing virtually nothing about macro executions to knowing a whole lot. We now have visibility into which users are using macros at all in our organizations, where these documents are executing from, and whether these documents are doing strange things like dropping executables or scripts, talking to Azure or Cloudflare or DigitalOcean, loading DLLs that are needed for COM, WMI, or .NET functionality as well. So going back to our graph for a second, we've now gained some visibility into macro executions. We've baselined that activity. The discovery of odd and malicious behavior is an ongoing process. So now we need an alerting / filtering strategy. And this will tell us if something malicious or strange is happening in our environment. So this graph on the slide is not complete due to space constraints, but it's a nice mental aid in helping us think about how to alert on or filter malicious macro usage. And as I mentioned earlier, it's very difficult, if not outright impossible, to have a simple yes or no regarding malicious macro usage. And there isn't a particular trait in macro executions that make it 100% malicious. So those of you who've done any kind of detection engineering work already know that even something like when we're spawning a command prompt or PowerShell unfortunately happens in production environments, for example. So to begin to tackle the alerting / filtering problem, we need flexibility. And here I'm using a query described by Alex Thierry as a hyperquery. And Michael Haggis also has an example of this type of query for PowerShell logs. So I just want to be clear that this query isn't my idea. I'm just applying it to malicious Office macros. And the scores or qualifiers here need to be adjusted for your environment. But in my examples, I'm adding values based on certain activity and I'm lowering the values based on other type of activity. So for example, if PowerShell spawns from Word, the score goes up a little bit. If the macro is executed from a trusted file share, the score goes down a little bit. And I should note too that the screenshot here doesn't have the full query, again, due to space constraints, but the full query is available on the GitHub link, which I'll make public shortly after this talk. So let's look at some results from this query. And if we look at just a basic example on row 1, that's just a macro that spawns PowerShell. And row 2 is a test macro that doesn't spawn any processes at all and is open from a file share that we trust. So we can see that spawning PowerShell raises our score, and that's in the first row. And opening the macro from a trusted file share lowers the score, which is the second row. And you have control over these levers and the score that you want to assign to particular actions. And it's important to note here that just because a macro executed doesn't mean it's malicious. Here, context matters a lot, and the more data that you have, the more context you're able to add, and the more quote unquote intelligent your score could be. So let's look at some other examples, and this time we'll use the Atomic Red Team framework, which is amazing. If you haven't checked it out, I highly recommend that you do. And the first test is an OS tap style macro execution, and we could see the various qualifiers that are triggered, including a WMI DLL load and a suspicious file being created. The second row there, Atomic Test 3, is a maldoc choice flags command execution, and this uses abnormal command line arguments for its execution. So we could add a qualifier for all that, including command prompts spawning from Word, as well as the command line flags. Atomic Test 6 there, the third row, that is an Excel for macro payload, which is a little bit stealthier, but we can still see the VBE7 DLL being loaded, as well as a suspicious VBS file being created. So using my implementation of this kind of scoring system, we can see the benign macros are scoring at about 20, whereas the more interesting macros are scoring at about 60. So WMI, you've heard about WMI in some previous presentations here, but it's worth calling out separately in the context of Office macros, specifically because its usage can be used to bypass or break parent-child process detections. So from a defensive point of view, that's obviously a little bit scary. So in the first screenshot, we could see our test calc payload spawn from WMI PRVSC and not WinWord directly. However, not all hope is lost, and we could increase our score based on the image load events which occur when WMI is called from a VBA macro. In addition, if we go looking inside the call trace field of the Sysmon event ID 10, we can also see some WMI functions being called. And these functions and DLL loads can all be used to increase or lower our score. And if you're interested in Sysmon event ID 10 and you want to learn more about how to translate these function calls, we wrote a blog post on the Lars blog a couple months ago. So if that's of interest to you, definitely check it out. So similar to WMI, PPIT spoofing macros can be used to break process relationship chains. And the goal of this particular PPIT spoofing macro is to make it look like PowerShell spawned from Explorer and not Windward. However, if we look at event ID 10, we could see the Windward process accessing the memory space of PowerShell.exe. So even if process creation events are lying to us, we could still use the process access events to give us the real story. And then we could go and add these events to our qualifiers, which is what you're seeing in the very bottom image highlighted below. So let's look at one last example to help solidify the ideas that we kind of talked about so far, and that is Gadget to JScript. And this little program can turn a .NET assembly into VBA code. So this is a potentially, very cool and potentially stealthy technique. So how do we approach this? So let's build a test payload first. That's going to be your first step. And then you can use Office Shush and compare what events you see with a Gadget to JScript macro versus a normal macro. And then you could go ahead and add these differences to Office Sus or your existing tooling, and then add the relevant qualifiers and scores to your alert. And the results that we see here are interesting. We see the CLR DLL being loaded by Word, and we also see a bunch of .NET native images being loaded by Word/Excel. So we could go ahead and add all this to our qualifiers and our configuration files. So if we score this .NET macro, we could see that the score goes well over 100 now when all the different factors are accounted for, whereas a normal macro executing from a trusted source gets a score of about 2. So I thought this was a really interesting and cool dynamic to illustrate. So during the presentation, we focused a lot on the endpoint when looking at malicious Office macros, but it's important to look at the bigger picture as well and kind of shine the visibility light into other areas that just aren't the endpoint. The phishing email that contained the macro has to get emailed to your user somehow, and there's a lot of visibility opportunities here in addition to the host-based telemetry that we've been discussing so far. The executed macro also usually establishes some kind of command and control as well. So having a network layer visibility, particularly the ability to tie a network connection to a process, is extremely helpful here. So while it's incredibly fun to look at endpoint telemetry, when it comes to malicious macros, there's huge detection opportunities to be had on both the left and the right side of our poor victim user here in the middle. And finally, to kind of wrap things up, I think it's important to have long and medium-term goals when it comes to protecting your network and its assets. And Office is a massive, massive attack surface. I would argue that the attack surface is similar to that of PowerShell, but unfortunately, we're not provided the same level of visibility and telemetry into VBA tradecraft as we are with PowerShell. So what this means is that it's next to impossible to keep up with detections for macro/VBA tradecraft. And if you want a little sampling of this, Google the maldoc hashtag on Samir Busadin's Twitter feed where he breaks down all this tradecraft, and your head will literally explode. The longer term goal for all your baselining and detection methods, should be prevention, and that's disabling of execution of untrusted macros. And as always, John Lambert is ahead of the curve here and describes this dynamic expertly, and that's in the screenshotted tweet. So doing this kind of hardening is an incredibly difficult thing to do, but it's definitely worth your time and effort to spend resources on, and hopefully the information contained in this presentation kind of aids you in that effort. And that's all I had. Thank you.
All right, thanks, Anton. That was a really great presentation. In fact, a lot of people in your hallway exactly saying the same thing. We only have a couple of questions in there, but I think that's because they're not people aren't really mostly sure what to ask yet about this. Um, but I do have one that I wanted to bring up. I'm just scrolling up right to the top. So you talked about the XML files like Office Shush and things like that. And one of the questions was, can they also be used against Office 365? Or maybe I'll extend that. And if not, are there similar things that can be used?
Yeah, that's a great question. So if you're using like the web version of Office 365, then no, this wouldn't apply. But if you're installing like the full Office suite and logging into it with your Office 365 account, then yes, that's all applicable.
Perfect. Well, I think you have a long queue of people who are waiting to talk to you in your
Awesome.
hallway.
That's awesome.
So thank you very much for
Of
being
course,
with us today. Very
my
much
pleasure.
appreciated.
Thank you.